Hi, I'm Eusebio Rufian Zilberman from Long Island, New York. This is a presentation for the course Introduction to Music Production. Today's presentation is about the topic of distortion in audio signals. Distortion happens during amplification of an audio signal. So first, let's see, what is amplification of an audio signal? Amplification or attenuation is the normal operation mode of an amplifier. In this mode, the output is the result of the input multiplied by a constant value. When operating in an amplification or attenuation mode, the shape of the output is the same as the input. The transfer function of the amplifier is a single straight line. This is why we say that the amplifier is operating in its linear zone. Then, what is distortion of an audio signal? When an amplifier is operating near its limits, the following things happen. First, the output can no longer follow the input. Then, the shape of the output becomes bent or clipped compared to the input. This difference in shape is what makes us say that the signal is distorted. Third, the transfer function is no longer a single straight line. It's either multiple lines or a curved line. We say that the amplifier is operating in its non-linear zone. Let's compare the wave shapes when an amplifier is operating in its linear zone and its non-linear zone. In the three pictures above, we can see the original signal, then the amplified signal, which has larger amplitude, and third, we see the transfer function, which is a straight line. In the three pictures below, we can see the original signal, the distorted signal, which has a different shape, and the transfer function, which in this case it consists of two straight lines with one horizontal segment that represent the clipping zone. In a typical production scenario, we want to reproduce accurately the original signal. Most distortion is undesired when recording. In general, we have two types of distortion. One of them is soft distortion, which is less unpleasant than hard clipping. For soft distortion, when the amplifier is operating near its limits, what happens is that the transfer curve slightly bends towards the upper bounds of the operating limits. Hard clipping is more common of digital signals. When a certain maximum level is reached, the signal just stays at that maximum level. For hard distortion, the transfer function is composed of two segments. One of them corresponds to the linear part, and then there is a horizontal segment that corresponds to the clipping. Hard clipping can also occur when recording plosive sounds. This happens typically with voice recording. For example, the P sound. This is voice without distortion. This is voice with soft clipping. This is voice with hard clipping. Not all distortion is undesirable. Distortion can be useful as a musical effect. It is typically used as a part of the guitar amplification chain, or also the bass. When applied to simple signals, our brain no longer perceives this distortion as added noise, but as a timbre variation instead. The simpler the signal, the harder the distortion effect that can be applied without it being perceived as noise. This is a guitar sound without distortion. This is a guitar sound after applying distortion. How is it that distortion can be perceived as a timbre variation? Well, the easiest way to observe it is in a sine wave. When we take distortion to the extreme, a distorted sine wave becomes a square wave. Compared to a sine wave, a square wave has a richer content of upper partials and has a brighter and louder sound. In summary, audio signal distortion is an effect that results from non-linear amplification of an audio signal. Distortion should be avoided when we want to reproduce a signal with fidelity. Distortion can be useful as an effect for timbre variation when applied to certain specific signals. That's all. Thank you for listening.